Hello, everyone. Welcome to the seminar on slow mathematics. Um, I have Raghunath with me. Hello, Raghunath. Are you able to hear me?
Yes, sir, I can hear you.
Okay, that's
Y- Okay.
somehow I'm able to hear a echo, but I hope that's okay from
Oh,
your end. Can you hear me properly?
yeah, I can hear you without any echo.
That's great. That's great. So, those of you who are viewing right now, welcome to another live seminar at chinta.com. Today, we want to talk about a very interesting problem solving strategy, especially for young children in school, uh, grade 1 through 10, especially in early days like grade 1 through 6, 7, 8, and so on. We have been doing this experiment for quite some time. Raghunath is spearheading this particular process. He is helping out so many children in this regard. And I will tell you more about this particular experiment with learning. It has been going quite interesting for, I think, how many weeks are we doing this, Raghunath, right now?
So we are doing this officially for 3 months,
Okay.
which is like 12 weeks,
Okay, 12 weeks. Okay, that's quite some time
and
actually. And hundreds, many students have
that means
participated
six
from
fortnights.
yeah, different parts of the, from India, from outside India, and they have been working with these problem sets for quite some time. The main idea is actually quite simple. Every 2 weeks, we physically send these kids a set of problems and they try to solve it. There is space to do the problems on those worksheets, and then they send it back through WhatsApp. We grade them, and the process repeats again. In the next 2 weeks, we send a new problem set, and these problems are actually Olympiad styled. I mean, they are non routine problems. They make you think, they're not repetitive in nature. We call them slow mathematics because we think that you have to take some time to actually think about these problems. You have to take some time to solve them carefully, and they're not multiple choice in nature. So you have to actually write down your argument. You have to write down your argument, which is equally important. Now, in the current day and age, students are having a very small attention span. That's what we have noticed while working with Chinta. We work, I think right now we have about 750 plus students from India, United States, United Kingdom, and different parts of the world. Very good students who are really interested in mathematical sciences. But one of the things that we have noticed is that the attention span of the children are actually reducing. And one reason, we think one reason is this, that much of the mathematical activity that they're doing are multiple choice in nature. They do not have to actually write down the solutions that someone will carefully grade. So, this particular bi weekly program, which we call SuMON Math, there we actually carefully grade the responses that we receive from the students. That's a very important thing, to actually understand what you have written and carefully give you feedback on that. I'll tell you a little bit more about what motivated us to start with slow mathematics and some of the scientific research around this. I think it will be very helpful for the viewers. If you are a student or if you are a parent, a teacher, you can use these latest understandings about how human memory works and how learning itself works, and you can help your child, your friend, your student. So, right now, if you are a little kid, let's say in grade, uh, especially younger kids in grade up to grade 6, let's say grade 1 to 6. One of the things that parents do all the time is repetitive mathematics. They want you to learn multiplication tables. They often take you to an abacus school, a mental mathematics school. Sometimes they are called Vedic mathematics. They also tend to give repetitive exercise. The entire goal of all of these three or four processes is to improve the retention in the mind. They want the kids to actually memorize some of the aspects of mathematics, the calculation aspects at least. So, there is some research around this memorization and forgetting. There is a there are a couple of neuroscientists from and this was actually a paper that was published in Harvard Medical School. There was there are Andrew Butson and Elizabeth Kessinger. They did some research on why forgetting is important and how memory works, especially in young children. And there are a lot of other research around this single topic, that whether it is useful to memorize a bunch of stuff. And interestingly, one of the things that they found is that forgetting is actually quite important. What forgetting might do, and I'll obviously give a link to the main paper in this particular video's description. But what forgetting does is it helps you to sort of rebuild from scratch, rebuild and revisit the ideas that you already had, and now apply them in the present time. Now, every time you do that, every time you rebuild the logic, you are actually learning something. So that's what we say to our students as well. Like, there are live classroom programs at Chinta for these students. What we tell them over and over again is, do not worry too much about memorizing. Instead, think about solving problems that make you think. And these problems are the ones that we call slow problems. So I'll give you one example, and these are the type of problems that Raghunath and his team are actually creating. So these are modeled after existing Olympiad problems, Russian math circle problems, and so on. But we try to create the problem fresh. So we have a team here who is actually working really hard day after day, week after week, to come up with new problems. That's a lot of fun actually, thinking about new problems which can make the kids think. And there are also games that uh, Raghunath and his team has been thinking about. So some of the games that we use in our classroom include Kendaku. Maybe you have heard of Kendaku. Kendaku is a very interesting game from Japan, which also which integrates. It's like Sudoku. It looks like Sudoku, but it is more complex. It integrates components from regular arithmetic, but it also helps you to build logic. It helps you to go to the fundamentals of mathematical problem solving, like casework, like what works, what doesn't work, divide and conquer strategy, and so on. So there are games like this that Raghunath and his team also works on consistently. I will strongly recommend students to actually check out SuMONMath.com. It's actually the link will be given in the chat description. But Raghunath, could you tell me a little bit more about the process of creating problems and what is motivating you guys to actually, do these things? Uh, can you tell us more about
Yeah,
this?
sure. So actually, we started this Shumon because the problems that are involving critical thinking is lesser in number when compared to problems that are just solved, just to numerically calculate. So we
Right.
want to promote that and create more resource for that. And
Right.
eventually we will be also able to write a book on that. And
Right.
that's one of our goal. As well as we want students to not only, nowadays students not only stay in their place, they move around, and they tend to go out of their the usual classes. And
Right.
they usually ask how to be concentrated and how to think about math while we are away from our home, or while we are away from our environment to study, or away from school. So this particular method will help you, because this is a hard copy that is sent to you every fortnight. So you are
Right.
going to take that in hand. So that's really a very easy thing to do. And you can think about just sitting in a park wherever you go. So that is our motivation to create these problems and send this as a hard copy in the first place. And also, as I told, the problems require a lot of thinking that usually takes at least 2 hours to crack a problem. So student need
So,
to
so you're saying to crack one problem, you need student might need to think of for a couple of hours. Is that what you're saying?
exactly, exactly.
Wow.
So
So
we
you see how different this is from repetitive problems, right? It's not like you plug in a formula and you do one of them and then you go to the next problem, which is basically the same problem. Just you have to plug
exactly,
in another formula. It's not like that. This is
exactly.
very different. Yeah.
We don't want the calculation to be the main part of a problem. We want
Right.
the underlying phenomena to be determined of each problem.
Exactly. The underlying logic or
So
the underlying reasoning is coming to the center
yeah,
stage instead of the calculation part.
yeah,
Absolutely. Yeah.
exactly. So also this demands the interest from students side. So that is the
Yeah.
reason why we involve activity related problems like paper folding and constructions. And they can
Right.
also have some, cube. They need to form a cube out of a paper, and they need to paint it in such a way that there are no adjacent faces with same color. So these kind of
Okay.
activities are involved.
So coloring problems. You know,
Yeah,
there is a there was a very interesting set of problems that was used in International Mathematical Olympiad since its inception, and this is the real International Math Olympiad, by the way. These are often called coloring problems. Coloring problems would it would be actually combinatorics problems in disguise, but they would also make the entire process very visual. So
right.
at the early
Yeah,
stage, what Raghunath is suggesting is that if at the early stage, if we can have these activity based thinking problems, I would say like that, activity
yeah,
based, but they are thinking problems, those would be very effective.
yeah. The students will now be involved to do that. Even if
Correct.
it lasts for hours, they would be involved to do that. And that's the
Absolutely.
kind of thing. And we also do some Olympiad style problems, like the paper contains 4 easy problems and 4 hard problems.
Okay.
So we will give them like 3 activity based problems and
Mm-hmm.
3 Olympiad style problems and
Right.
one easy problem, which is not much you know pain has to be put to crack that. So
Correct.
that's the strategy for designing these problems for the kids.
Yeah. You know, one thing I remember whenever you guys actually put together these problem packets, one thing that it reminds me is of a competition called Tournament of Towns. There was a very
Right.
beautiful competition called Tournament of Towns. It was, I think, conceived in the Soviet Union, the USSR, and
Yeah.
the problems in this particular competition would be actually quite different from regular mathematical Olympiads. These are like classic low tool problems, problems that do not require the student to learn a lot of elementary knowledge, to know a lot of form. It doesn't require the student to know, in fact, anything. The student can actually meditate on the problem, draw miniature diagrams, play with some of the cases, and then come out with the results. And they
Right.
were like very popular, and it's still, I think, on. I think it's
Yeah, it is still
active.
ongoing. Only
Yeah,
in few parts of the world they are inviting students. So they need,
exactly.
if they are willing to travel, then anyone can write this exam.
Oh, okay.
So it's a
That's
very nice
fantastic.
experience. So it is
Exactly.
also
Tournament of
given in
Towns.
Toronto in Canada, as well as
Toronto, right.
Russia is the conducting place, and in
Right.
many parts of the world it is conducted. So students can
Right.
travel and will definitely get a good experience. So these
Excellent.
problems are like they can devise their own strategy to count. Mostly the problems
Exactly.
are counting oriented, so
Uh-huh.
it's always countings are not simple, so they
Right.
can
Counting can
be,
be complex.
yeah, we do not have tools for counting. For each problem we need to devise our own strategy, and
Correct.
students need to work on these problems more. So we also try to give problems in that aspect.
Right. Excellent.
Actually.
So I will not prolong this discussion. Thank you all for watching this particular live session. If you like to have some time away from your computer, to have physical, beautiful problem sets every 2 weeks, to challenge your mind with it, then definitely go to sumonmath.com and uh, you can register for it. The first week is always free. You can try it out. I wholeheartedly believe that this really adds a lot of value to the learning process of the students. Thank you, Raghunath, for the wonderful work that you and your team are doing. And hopefully, we will be coming back to these ideas more and more. Okay. Thank you.
Yeah, sure.
Oh, there is
This
a
is a
question actually. What grades? So, Raghunath, what grades the students can
Yeah.
join?
So we are having four categories in here.
Four
The
categories.
level one is for grades 3 and 4.
Level
Level
one is for
2,
grade three and four. Yeah.
yeah. And level 2 is for grades 5 and 6. Level
Right.
3 is for grades 7 and 8. And
Uh-huh.
level 4 is for grades 9 and above.
Excellent.
Yeah.
Yeah. So there are starting from grade three, students can do it, and we
Yeah.
see that students from different parts of the world are actually, yeah,
Actually, students who have completed their high school can also participate in this.
yeah, anyone
Level
can
4
participate,
problems.
even if you are like an adult who is interested in mathematics, you
Exactly.
can do it. Yeah. Okay, so here is another question. Can you suggest us some exams like the tournament of towns for Indians? Well,
I see. Actually, there is a exam called as Purple Comet, which is team-based exam. That
okay,
is also for Indians. You
okay,
can give it online in teams under a supervisor. That
Acha.
exam is kind of like Tournament of Towns, so you can try that out.
Are the problems
It,
good in Purple Comet?
yeah, the problems are good. They are slightly Olympiad based,
Okay,
so but it's a good experience.
great, 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 awesome. All right, if you have more questions, feel free to reach out in the website. We will be always happy to collaborate with anyone who is interested in mathematics. Thank you, Raghunath, for joining in, and we will keep the conversations on in the future live sessions. Okay. Thank you,
Sure.
everyone.
Yeah. Thank
Okay,
you.
okay.